In this example, we're going to ask the very important question, are Beanie Baby bears cuter than Beanie Baby cats? Now, according to Beep Beep, this is one of the most important questions addressed in the field of statistics. Now, we have a bunch of data here, and we've got data on the cuteness level of a bunch of bears and the cuteness level of a bunch of cats. And before we analyze it, we need to be really clear on whether we have a one-tailed or a two-tailed hypothesis. Now, if we have a one-tailed hypothesis, we have more power to detect differences. But if we don't know what direction it's going to go, we want to be able to detect differences in both directions. We should make a two-tailed hypothesis. So we should make a one-tailed hypothesis if we have good theoretical reason for doing it, and we're not interested in it if it goes the other direction. Now, according to Beep Beep, we do have good theoretical reason for believing that Beanie Baby bears are cuter than Beanie Baby cats. And that's that bears are warmer and fuzzier than cats. So I think we're going to go with Beep Beep's hypothesis. We'll make it a one-tailed hypothesis. And that will be the average cuteness of Beanie Baby bears is greater than the average cuteness of Beanie Baby cats. And so this is a one-tailed hypothesis because we say that the average for bears is going to be greater than. It would be two-tailed if we simply said it was different. Now we could have made a one-tailed hypothesis in the other direction, saying that cats were cuter than bears if we had a good theoretical reason for doing that. But we don't. Now, in this hypothesis, we're saying that the average cuteness of Beanie Baby bears, so what do we mean by that? We mean that if we were to have all Beanie Baby bears in the world, their average would be higher than the average of all Beanie Baby cats. Now, of course, we don't have that. We've only got a sample here, and so we're going to use a t-test to find out if whatever the difference is, and undoubtedly there's a difference unless by chance it came out exactly the same, if that's significantly different, and we can apply the difference in the sample to the population. Now, we could also simply make the hypothesis that Beanie Baby bears are cuter than Beanie Baby cats. That would mean the same thing. When we say that Beanie Baby bears are cuter, we mean that the average cuteness of Beanie Baby bears is greater than. So sometimes we abbreviate it and we don't say the average, but we're always talking about averages when we're doing t-tests. All right, so let's do some calculations. The first thing we're going to do is we're going to get the descriptive statistics. So we go to data. So let's go to data, data analysis, and we're going to get descriptive statistics. I click OK, and we want the two columns. So I'm going to start up here at C5 to D26. Oops, I have that in there already. And the output range I'm going to make at F5. Oops, let's correct that there. And I'm going to press, I've got summary statistics, and I've got labels in first row. So I'm going to press OK. And let's get rid of some decimal points. We've got the number format, and here we've got the mean is 6.71 for bears and 5.32 for cats. Now, so far so good. 6.71 is greater than 5.32. Now, if it turned out that the sample for cats was higher, then we could just stop there and say that the hypothesis was not supported because our sample didn't even give a difference. What we need to a difference in the hypothesized direction. Here, the difference is in the hypothesized direction, but now we have to test to see if it's significant. Now let's get some other descriptive statistics here. We want the mean, the standard deviation. So it's about 2.5 for both bears and cats. And then we want the count, that's n. And so with these three numbers, we can describe the distribution of bears and the distribution of cats. And we always want to report those three numbers, the mean, the standard deviation, and the count, for any sample that we have. So now we want to go to a t-test. So let's go to data, data analysis, and we're going to go to a t-test to sample, assuming equal variances. I press OK, and I'm going to erase the data that I had in here already. Delete. So the first variable is going to be the bears. So I'm going to go from C5 down to C26. The second variable is going to be the cats. Control Shift. Now, so we've got fewer cats, but that's fine. So we'll go to D5 to D24. The hypothesized mean difference is 0. We've got labels in the first row, and the output range I'm going to put at K5, and we press OK. Let's get rid of some of the decimal points. Home, number format, number. Let's make this first column bigger. And so we have the mean, and now the t-test doesn't give us a standard deviation, it gives us a variance. That's the square, but we'll use the standard deviation there. We've got the degrees of freedom, 38. The t-stat is 1.76, and the one-tailed t-test is 0.04. Hooray! That's less than 0.05. Let's give it an extra decimal point, 0.043. And so our hypothesis was supported, just barely, 0.043. And that's because we have a pretty small sample of bears and cats. Now notice that if we had made a two-tailed hypothesis, it would have been p equals 0.09, and it wouldn't have been significant. So it was a good thing we made a one-tailed hypothesis. Now we need to write this up in APA format, and so I'm going to actually copy it in here so you don't have to watch me struggle typing all the italics. And we have the hypothesis that Beanie Baby bears, and then we report the mean, the standard deviation, and the n, and all three of those are italics. And then, so it's italics, space equals space, and then 2 decimal points for everything. Are cuter than Beanie Baby cats, and again, we report the mean, the standard deviation, and the n, and the M, S, D, and N are all in italics, and you put a space before and after the equal signs. Was supported, and then we report the statistic as T in italics, no space, and then the degrees of freedom, 38, in parentheses, and then space, and oh, look at that, I forgot to put a space after the equal sign there. So I will do that now. Equals 1.76, P in italics, space. Oh, did I forget to put another? No, I put the space before the decimal point. Yeah, I did. So that's good. So P space equals space 0.043, one-tailed, to indicate that we had a one-tailed hypothesis. So that's the APA format of reporting the t-test, the average between 2 independent means.